Hello everyone. This lesson we're going to talk about three-phase system. Before we talk about three-phase system, we're going to tell you the advantages of three-phase system. The three-phase system, they can build smaller machine for the same kVA. So if I want to deliver same amount of power with three-phase system, I can build a smaller machine to deliver the same amount of kVA compared to single-phase system. Second one, when we use three-phase system to deliver power, we can use smaller conductor. We will show you how we can achieve that. So when we use smaller conductor, we use less coppers. Third one, the three-phase system, we can deliver constant power to the load compared to single-phase system. Because in single-phase, we have one sine wave. The sine wave always will reach zero. For three-phase system, the system always get power. They're never going to have a moment the power reach zero. The last one, the three-phase machine is much easier, much simple to construct. For that part, you're going to learn in your AC machine topic. For three-phase motor, generator, it's much easier to build than single-phase. So that's the four main advantages of three-phase system. Now I'm going to show you how the three-phase is generated. So here is a simple three-phase generator. We have three sets of winding put 120 degrees apart in the generator stationary core. Then when the rotor or the armature is turning inside, or in this case, we have a rotating magnetic field, we have three stator armature winding being built in the stator, we generate three-phase AC supply. So this picture is all three sets of winding is set 120 degrees apart in this machine. And when this magnetic field is rotating inside this machine, we generate three sine waves at the same time. Each sine wave will have reached the minimum value, reach the peak value, reach the negative maximum value at a different place. The horizontal one is the time, the vertical one is the amplitude. So for phase A, we start from 0, we reach the top, then go to 0, negative. So these three sine waves, they are generated at the same time. When this machine turns to a different location, different phase, we reach the peak value. For last three slides, you can see when this rotating magnetic field rotating in the machine, so each different location, different place, the three-phase sine wave, they each gonna be reach the peak value. For three-phase machine, we can generate the three-phase AC in two different sequences. So three-phase, we have two-phase sequences. One phase sequence A, B, C. Another one, phase sequence A, C, B. What those letters indicate is when phase A reach the peak, next one gonna be phase B reach the peak value. Then phase C will reach the peak value. If they in this kind of sequence, we call the phase sequence A, B, C. If phase A reach frequency peak first, phase C reach peak next, phase B reach the peak value the later, that phase sequence is going to be ACB. So in three-phase, there's only two phase sequences, ABC or ACB. When doing three-phase, we review the vector for a purpose. The vector is when we're using to analyze three-phase supply or three-phase load. So we do some vector diagram to representing three-phase voltage or current. In here, if I'm going to representing a voltage value, I will draw the vector. If it's a voltage, the end of the arrow pointing the direction of this vector. The end of the arrow will be open end. You can see I draw them this way. So here might be my next voltage vector. Here will be my three-phase voltage vector. So this is representing three-phase voltage vector. If I draw in a current vector, I use a close end to representing the current vector. Here will be the vector diagram for three-phase current. And when we draw vector diagram, the direction of this arrow, or we call the current direction, is always from the source to the load. That's going to be showing you in next lesson. If you have a question or you want to talk to us, you can connect us online or send an email to us.